Have you ever wondered about the different types of hydrogen? Hydrogen, the simplest and most abundant element in the universe, is a bit like the superhero of elements. It's light, it's powerful, and it's everywhere, playing a vital role in the existence of stars, including our own sun. But did you know that not all hydrogen is created equal? That's right, hydrogen comes in different types, each with its own characteristics and uses. The three main types are green hydrogen, gray hydrogen, and blue hydrogen. Green hydrogen, produced by splitting water molecules using renewable energy, is the cleanest form. Gray hydrogen, the most common type, is produced from natural gas, releasing carbon dioxide in the process. Blue hydrogen is basically gray hydrogen, but with a twist. The carbon emissions are captured and stored or reused, making it a more environmentally friendly option. Now, let's dive in to explore each type of hydrogen in detail. Gray hydrogen, the most common type, has quite a story. Our journey begins with steam methane reforming, the principal process through which gray hydrogen is produced. It's a fascinating process, really. Natural gas, mainly methane, is exposed to high-temperature steam under pressure. This interaction results in a series of chemical reactions that ultimately form hydrogen and carbon dioxide. While the hydrogen is collected and put to use, the carbon dioxide, a potent greenhouse gas, is often released into the atmosphere. Now you may be wondering, where does all this gray hydrogen go? Well, it's actually quite ubiquitous. It plays a pivotal role in several industries, from ammonia production to refining and methanol production. Let's take a closer look. In the world of ammonia production, gray hydrogen is a key ingredient. It's combined with nitrogen to produce ammonia, which is then used to make fertilizers that help grow the food we eat. In the refining industry, gray hydrogen is used to remove sulfur from crude oil, producing fuels that power our cars and planes. It's not just limited to these industries. Gray hydrogen also finds its way into methanol production, playing a vital role in the creation of this versatile chemical used in various applications. However, as integral as gray hydrogen is to these industries, it's not without its caveats. The elephant in the room here is its environmental impact. The steam methane reforming process, while efficient, has a high carbon footprint. The carbon dioxide produced during the process is often vented into the atmosphere, contributing significantly to greenhouse gas emissions. This is a stark contrast to its sibling, green hydrogen, which we'll discuss later, that is produced using renewable energy and water, leaving virtually no carbon footprint. Despite its widespread use, gray hydrogen's environmental impact is a major concern. As we continue our exploration into the world of hydrogen, we'll look at how innovations are addressing these concerns, paving the way for a more sustainable future. Stay tuned. Blue hydrogen, often seen as a transition fuel, is the next on our list. Let's delve into the production process of this intriguing variant of hydrogen. Much like its gray counterpart, blue hydrogen is produced from natural gas through a process known as steam methane reforming. However, there's an essential twist in the tale. An additional step of carbon capture and storage, or CCS, is incorporated into the process. This technique aims to trap the carbon dioxide produced during the reforming process instead of letting it escape into the atmosphere. The captured carbon dioxide is then stored underground, significantly reducing the environmental impact. So, where does blue hydrogen find its applications? Well, the answer is pretty much the same as gray hydrogen. From refining petroleum and producing ammonia to fueling vehicles and generating electricity, blue hydrogen serves a multitude of industries. Yet, the key advantage it holds over gray hydrogen lies in its relatively lesser environmental footprint. Now, it's time to evaluate the environmental pros and cons of blue hydrogen. On the brighter side, blue hydrogen production results in significantly less carbon dioxide emission compared to gray hydrogen. This is, of course, due to the carbon capture and storage techniques employed. However, the effectiveness of this carbon capture poses a challenge. Not all carbon dioxide can be captured, and a certain amount inevitably escapes into the atmosphere. Moreover, the process of storing and monitoring the captured carbon over extended periods raises concerns. Another aspect to consider is that the production of blue hydrogen still relies on fossil fuels, primarily natural gas. This reliance continues to feed the demand for these non-renewable resources, which in the long run isn't sustainable. In essence, blue hydrogen offers a cleaner alternative to gray hydrogen, reducing carbon emissions and serving the same industries. However, the effectiveness of carbon capture, the reliance on fossil fuels, and the challenges of carbon storage pose questions that need addressing. Blue hydrogen provides a cleaner alternative, but is it the best we can do? Stay tuned as we explore the final type of hydrogen in our list. Green hydrogen, the cleanest of them all, holds a lot of promise. As the hue suggests, green hydrogen is the most environmentally friendly version of hydrogen. It's created through a process known as electrolysis, where an electric current is passed through water to split it into hydrogen and oxygen. But what sets green hydrogen apart is the source of that electricity: renewable energy sources like wind, solar, and hydropower. Now, you might be wondering, what's the big deal about green hydrogen? Well, it's all about possibilities. Green hydrogen has the potential to revolutionize many sectors, from transport to power generation and even industry. Imagine cars running on hydrogen fuel cells, power plants operating without burning fossil fuels, or industries cutting down their carbon emissions significantly. Sounds like a dream, right? But it's not just a dream. Green hydrogen brings us closer to realizing a zero-emission world. Unlike its gray and blue counterparts, green hydrogen production doesn't release carbon dioxide into the atmosphere. This means we could potentially use as much energy as we need without harming the planet. That's quite a game changer. However, it's not all sunshine and rainbows. There are challenges to face. The production of green hydrogen requires significant amounts of renewable energy. And as we all know, the availability of renewable energy is not yet at a level where we can fully rely on it. We need to significantly upscale our renewable energy infrastructure to make green hydrogen a viable option. Moreover, storing and transporting hydrogen is not as straightforward as it is for traditional fuels. It's a light gas and it takes up a lot of space, which makes it a challenge to handle. Plus, the technology for hydrogen fuel cells is still in the developmental stages, and it needs more research and investment. Green hydrogen could be the key to a sustainable future, but there are still hurdles to overcome. However, with the right focus and investment in research and infrastructure, green hydrogen could well be the power source of the future, lighting up our lives while keeping the earth green. Now that we understand the three types of hydrogen, how do they stack up against each other? Let's dive in. Gray hydrogen, the most widely produced type today, is generated from natural gas through a process called steam methane reforming. While it's the most economical to produce, it's also the least environmentally friendly, releasing a significant amount of carbon dioxide into the atmosphere. Shifting gears to blue hydrogen, it's essentially gray hydrogen with a twist. The carbon dioxide produced in its creation is captured and stored underground. This makes blue hydrogen a cleaner option than gray, as it significantly reduces the carbon footprint. However, it's worth noting that the carbon capture process is not perfect, and some emissions can still escape. Lastly, we have green hydrogen, produced via electrolysis, where electricity, often from renewable sources, splits water into hydrogen and oxygen. It leaves no carbon footprint. It's the cleanest type of hydrogen, but it's also the most expensive to produce due to the high energy cost of electrolysis and the need for abundant renewable energy. When we consider usage, all three types of hydrogen can be used in similar applications like fuel cells for vehicles and power generation. However, the environmental impact of their usage varies significantly. Gray hydrogen's high carbon footprint makes it less sustainable, while blue hydrogen offers a middle ground, and green hydrogen stands out as the most eco-friendly option. In summary, gray hydrogen is the most economically viable today, but carries a heavy environmental cost. Blue hydrogen provides a more sustainable bridge, capturing most of the carbon emissions during production. However, it's green hydrogen that holds the key to a truly sustainable hydrogen economy, despite the challenges in its production. While each type of hydrogen has its pros and cons, the move towards cleaner forms like blue and green hydrogen is a positive step for our planet. So, there you have it, an in-depth look at the three main types of hydrogen. We delved into the world of gray hydrogen, revealing its process and its environmental implications. We navigated the realm of blue hydrogen, understanding how it's a potential bridge toward a more sustainable future. And we ventured into the domain of green hydrogen, a beacon of hope in the fight against climate change. These types of hydrogen aren't just scientific jargon, they're keys to unlocking a healthier planet. They represent the past, the present, and the future of our energy landscape, and understanding them is the first step in making informed decisions about our energy consumption and advocating for cleaner alternatives. As we continue to explore the fascinating world of science, let's not forget the power we hold as informed individuals. Thank you for joining us on this exploration of hydrogen. If you found this video helpful, please give it a thumbs up, share it with your friends, and consider subscribing for more informative content.